Welcome back. This is a mechanic lesson in page 64 for grade 12, applying Newton's second law. Please follow me from your book. If you lift a book on your hand like this, suppose you make the book accelerates upward, means you lift the book upward at an acceleration A. There is two forces applied: the weight of the book working down and the reaction of your hand, which is trying to lift the book, action upward. Newton's second law is saying that F equals ma, means the resultant force equals the mass times the acceleration of the system. Here the resultant force is the difference between R and mg, because this is greater than this, because the book is going up. So R minus mg is the resultant force here, equals ma, the mass of the book times the acceleration of the movement. On the other hand, suppose you make the book accelerating down, means it takes you down. So it will be the opposite. The equation will be the opposite. mg minus r equals ma. In both cases, Newton's second law, F equals ma. The units of the F is Newton, and the m should be in kilogram. Means if it is in gram, you have to convert it to kilogram. And the acceleration will be in meter per second. If you go to exercise 4a, page 65, let's take some of them. Number 1, calculate the resultant force in newtons required to produce the following acceleration. A car of mass 400 kg has acceleration 2 meters. What's the force needed to move the car in acceleration 2 meters if it is 400 kg weight? The answer is F equals ma, so it's 400 times 2, which is 800 Newton. This is the force required. Number 2, a blue whale of mass 177 tons. Tons means in kilogram, you have to convert it to a kilogram, put 3 zeros. With acceleration half, what's the force required to move it half meter per second square in acceleration? Multiply this by this, you will need this force in Newton. The third one, a pygmy mouse of mass 7.5 gram. 7.5 gram should be changed to kilogram divided by 1000. Accelerate in 3 meters per second, then multiply it by 3 meters per second, and get the answer. This is some of the points in question 1. Question 2, a resultant force of 100 Newton is applied to a body. Calculate the mass of the body when its acceleration is 0.5 meters per second. The resultant force means F is applied on the body. The mass of the body, you don't know it, but the acceleration of the movement is 0.5. Then you can get the m, divide 100 by 0.5, you will get 200. Question number 3, I'll take the 2 points of question number 3. What's the reaction between a book of mass 0.8 kilogram and your hand when it is accelerating downstairs at 0.3? Accelerating downstairs means the weight is higher than the reaction of your hand, so mg minus r equals ma. So the mass of the book is 0.8 times the g, which is the gravity acceleration 10, minus the reaction of your hand equals the mass of the box 0.8 times 0.3, and then you can get the R, the reaction of your hand. The other case, moving upward at a constant speed, so you need to use the other equation, which is R minus mg equals ma, because it moves upward to get the R. This is the end of the lesson. Please do the exercise from 1 to 3 and submit it to me as soon as possible. Thank you.